Good morning, everybody. Welcome back to lecture number 7. Today, before we begin, I want you all to know how to solve equations of 2 variables or 3 variables using the calculator. I think the only allowed calculator are Casio and its equivalent calculators, not the ones with extra capabilities like Texas Instruments. We're not going to allow. Anybody has a Texas Instrument calculator? Yeah, we're not going to allow. So to solve it, you have to go to the mode of equation, and then you have to pick whatever equation. For example, it says ax plus by plus cz equal dn. What's important is you write your equations in the standard form, which is a matrix times the variable equals to another column. This column goes to D. The first column goes to A, B, C. It's not you put all of them equal to 0. That's wrong. You have to put equal to numbers to the right, and this you put it in the column D. Columns A, B, and C, you put the coefficients of your x, y, and z. In our EE234, x, y, z will be maybe V1, V2, V3, I1, I2, I3. Get it? It's important, okay? And we will do practice. Always bring your calculators to the lectures, okay? So any question from the previous material? So any question? Let's warm up with the checkpoint from last semester, from last lecture. Was this equation, right? So let me ask you a question. What is the current that goes through the 4 ohm? Conceptual question. You don't need to calculate anything. Okay, let's say plus minus from right to left. It will be 2 amp. Okay, if we put plus minus, what's the current that goes here? Minus 2 amps. What's happening is the 2 amps will get split to I2 and I3, and then they will be collected at this node going into this direction. So the current that goes from right to left, when I say right, means right off the board to left, is 2 amps. From left to right is minus 2 amps. So if I bring a question in the quiz 2, and we reverse the directions, you will be able to answer it, and then you're not going to complain about the time, right? Okay? Because part of the testing is the time. So how to solve this equation? Which one is easier? Can we find I1 and I2 before the V? Yeah. We're going to use CDR, current divider rule, right? So let's use CDR to the right. How many resistors in parallel? 2. So can we use the direct equation? Yes. Yeah, we can use the direct equation. So I want to calculate only I2. Did he ask for this resistance? He didn't ask for it. So let's calculate I2. What is I2? I2 equals
R2 over R2.
2 R2, which is the other R, over the summation. 2 over 2 plus 6 times 2 amps. Right? It's going to be 0.5 amp. Right? 10 seconds in the test. What is I1? How do we use CDR, or current divider rule? Current divider rule states that the current enters. So what's the current that enters the left parallel combination? Minus 2. So to get I1, we use the equation 10 over 40 plus 10. 10 over 10 plus 40 times minus. So this minus is because CDR, current divider rule, is for currents that enters. Okay? For currents that enter the node. if we reverse this direction, so it's minus 2, it gets splitted here and there. But we have I1 is from top to bottom. So we need to add another negative sign. So we have one negative sign to reverse the direction. So basically what we want to do is we want to do the minus 2 amp gets split into minus I1, but we will have to calculate I1. Another smart student would say minus 2 amp goes from the bottom will be split into I1. No, 2 amps will be split from bottom to top, and that's another way of solving it. And I think it's actually better to use CDR from top to bottom. So another approach is I1 equals 10 over 10 plus 40 times 2, where this 2 is current that goes through the 4 ohm resistor from right to left. So how many approaches to calculate I1? 2. 2, right? The smart student number 1 will say it's minus 2 gets splitted using CDR, current divider rule, but what we want is I1. So we have, once we find the current that goes from top to bottom, which is minus I1, we have to add another sign. So 2 negative signs. So what's the final answer? 20 over 50, 2 over 5 amps. You do the math. Same here, 2 over 5. Get it? The last point is what's the voltage drop across V? You can use parallel series combination, and then once you find R equivalent, you can use VDR. So one approach is we do it this way. What's the parallel combination between 6 and 2? What's your question? No, what's your question? That's okay.
It's always V, right?
No, it's not always. But before, is this point clear to you? Okay, so he's asking the voltage drop across the current source, like the quiz. Get it? So to calculate it, I want to simplify the circuit to look like that. And then I have plus minus. V, you can call it V, you can call it V current source. It's up to you. What is the voltage, what is the resistance equivalent? What? 1.5 ohms. Keep the 4 here. And 10 parallel with 40? 8. Are you sure? 8. So now we can use Ohm's law. We can't use VDR. Why we can't use voltage divider rule? Because we don't know the voltage here. So we can use KVL, Kirchhoff voltage law. So use KVL. Who wants to be the KVL today?
أنا أشوف أفضل دكتور إنه ناخذ البيك سيركت لأن عندنا الآي 2 والآي 1.
No, you already know I is 2 amps. So 2 amps will be flowing through the equivalent combination.
Even after.
Yeah, 2 amps will be flowing across because it's in series now. Half amp here, 1.5 amp there. So you can combine them and you know 2 amps goes here. As a matter of fact, you can combine all of them. 1.5, so let me redraw the circuit. Can I do it like that?
Yes.
What is our equivalent? 1.5 plus 4 plus 8, which is 13.4 amp ohm. So what is V, or V current source, which is equivalent to V? 2, current goes here is 2 amp, times 13.4, and you do the math. What's the answer? 26.8. 26.8.
Oh, but it's 13.5, not 13.7.
Whatever. Doesn't matter. 27. Who said 21? Get it? So now you have the solution of this problem. So if it came in homework 2, you will be able to solve it, right? Get it? Any question about current divider rule or voltage divider rule? We learned a lot from this checkpoint, right? So what we learned is that you have to be smart in managing the directions, and you have to make sure that you can use current divider rule if and only if you're confident about the direction and that all the elements are in parallel. And we can use how to simplify the circuit. I want to simplify it to a current source and a simple equivalent resistance. And that's what we did here.
بالنسبة ل8 أوم المفروض البولاريتي يكون عكس.
Forget about the polarity for now. The polarity is from plus minus. You are right about it. But we didn't do a KVL. We combined all the resistors. You are right. We should put plus minus because the current that goes here. You are right. I was wrong. So put plus minus, but we are combining it into one equivalent resistance. So today's lecture is nodal voltage analysis. What did you guys notice about the previous methods? It has some sort of randomness, صح? If you're lucky enough, you might get it. If you're not lucky enough, you might say, oh, I need a standardized approach. We need standardized approach. So let me read this. So the network analysis methods that we have learned so far are useful, but they do not apply to all networks. For example, if you have this circuit, is R1 in parallel with series with any other element? No. Is R2 or R3 series or parallel? So all of them are neither. So R5 and R4, they are not in parallel. R4, R5 and R3, they're not in parallel. I think we cannot zoom using all of you can see the circuit now? So what is the problem with this circuit? We have a current source, we have current splitted here, we have current splitted there. So you can't use VDR, voltage divider rule, you can't use current divider rule, KVL will be a miss, KCL will be also a miss. You have 1, 2, 3 nodes. So there must be a standardized approach. A standardized approach that you go through a process. And students love nodal voltage because you just have to go through the process. Nodal voltage analysis, key information about it. We love to have known currents in our nodal voltage analysis. Even though its name is called node voltage analysis, if we have currents, we love it because it makes our life easier. We call it node voltage analysis because we solve for the voltages in the system. So in this example, we want to know what is V1, what is V2, and what is V3. Now, it uses the concepts of, at this we call it node 1, node 2, node 3. The key idea here is we develop a KCL out. So we're going to get the current through R1 plus IS plus the current through R2 equal to 0. That's equation number 1. Equation number 2 is the current through the R3 plus the current that goes through R2 plus the current that goes through R4. And we equate it to 0. Because n equal out, where n is 0, out is all the out equations. At node 3 is minus IS plus V3, the current that goes through R4, plus the current that goes through R5. So 3 equations, 3 unknowns, you can solve for V1, V2, and V3. Okay, let me go through the process with you. So we cannot solve this circuit by combining resistance, series, parallel. Basically, we can't find shortcuts. The voltage division and current division rule does not apply. VDR does not apply because we don't have series elements. CDR, current divider rule, does not apply because we do not have parallel elements. We will learn node voltage analysis, which is general technique that can be applied to any circuit. And we love it. Students love it. So here are the steps. Step number 1, select the reference node. What does it mean? Reference node means select a node where you have 0 voltage. Do you remember in the lab? In the lab we had usually the lower. So we selected this V0. Why we select this V0? Because when you calculate, for example, the current IE, you have to use the equation V over R3. V2 over R3. So let me zoom in through this element. What is IE? IE equals V2. So V2 plus minus V2 over R3. We select the reference voltage because in reality, the voltage drop across the resistor is V2 minus 0. Get it? If V2 was, if this was 2 volts and this was 5 volts, the equation is actually going to be the voltage drop across the resistor, which is 5 minus 2. So you select a reference voltage to make it 5 minus 0 so that you can apply the method. So this should be IE. In other words, the key element here, across any resistor that has nodes 2 and 3, if you have an R, the current from I to 3, you put plus minus, is going to be V2 minus V3 over R. Why we select a reference voltage? To eliminate this and make it 0.
Doctor, the key must it be between 2 nodes?
This for any element, for any resistor that has a point A and B, this node has a voltage VA. This is measured with respect to the reference, 0. This has a node VB. So in reality, I told you before, this is AVAB, right? Which is VA minus VB. The voltage drop across this element is VA minus VB. Using Ohm's law equals to IAB times R. But I want to calculate IIB, so IAB equals VA minus VB over R, which is similar to that. Now, if we have minus something, we must have a reference in our circuit. So step number 0 is you have to select where is the ground. And now the ground comes in a useful case. And now we see why it's important. Because if you have the ground, if you know the voltage here is 5, we're measuring it with respect to 0 volts here. If this ground was 1 volt, this has to be 6. Because 6 minus 1 is 5. If this was 5, we're measuring it with respect to 0. Remember I told you, voltage is difference between 2 points. So you find the point that has usually at the lowest level, and then you make it 0. Get it? In other words, إذا أعطاك إياها في الامتحان جراوند هنا رسمها جراوند 3 خطوط خليها. ما أعطاك خليها تحت عشان ما تتورط. Get it? Step number 0. Assign node voltages. How many nodes we have? إيش تعريف النود? Where 2 elements are connected or more. Here we have a node. When we say it's the ground, so we don't count it. لأن نعرف الفولتج هنا 0. So we have 1, 2, 3. So you do KCL at node 1. N equal out. KCL at node 1. N equal out, صح? What is N? You draw all the currents out from the node. So 0. I A plus IB plus IC. What is IA? IA is V1 minus 0 over R1. We can call it V1 minus 0 over R1. What is IB? IB is V1 minus V2 over R2. V1 minus V2 over R2. plus. Remember we say plus because this is out. What is that IC? Is nothing but IS. You keep it. IS is known. You keep it. So this is equation 1. How many unknowns we have? 1, 2, 3. V1, V2, V3. So nodal voltage analysis, our goal is to calculate, your final answer should be V1, V2, V3. And I told you, we love having current source in nodal voltage analysis because it gives us a known value here. So we don't need to use V1 minus V2. We don't need to add variables. At node number 2, I'm going to do the equations mentally. ID is actually minus IB. ID is V2 minus V1 over R2, which is this equation. ID is V2 minus V1 over R2, which is minus IB. Do not confuse, keep them as they are. We write them as a function of voltages. Equation IF is V2 minus V3 over R4. Equation IE is V2 minus 0. Put the minus 0 like I did here, so that you don't confuse yourself. And if you notice here, V2 minus 0, which is V2 over R3. So this is equations number 2. So let me write them. V2 minus V1 over R2 plus V2 minus 0 over R3 plus V2 minus V3 over R4. So this is equations number 2. Equation number 2. We still have one more equation, which is equation number 3. V3, N equal out, N is 0. Out is minus IS plus V3 minus V2 over R4 plus V3 minus 0 over R5. So the key here is this equation. 1, 2, 3, that's the key. It comes from Ohm's law, V equal IR. So I equal V over R. بس اللي أبغاكم تفهمونه يا شباب إنه what we mean by the voltage in previous examples when we say what is V, it was actually, for example here, in the previous examples, this V is actually 12 volts, 12 with respect to the reference, which was the ground. So the ground was here. This V1 was not with respect to the ground. It was across the resistor by itself. So in resistors, we find the voltage drop across the resistor, and we assign a reference voltage so that we do not have V4. If we have V4 معادلة من 4 مجاهيل, it's too much. Once you do it, you have to write it in the standard form. How do we write it in the standard form? See what I'm going to do right now. So this equation is not written in the standard form, and this information is not in the slides, because I want you to watch the YouTube videos and attend the class. So how to write it? To write it, you have to make everything, you start V1, V2, V3. So what are the coefficients of V1? 1 over R1 plus 1 over R2. So you're going to say 1 over R1 plus 1 over R2 times V1. What are the coefficients of V2? Minus 1 over R2. Plus minus 1 over R2 V2. What are the coefficients of V3? 0. And then equals a number. What is this number? Minus IS. That's the standard form. So this is math 001, standard form. To solve equation with 3 variables. Standard form. Remember 001? Who skipped 001? Review it. Okay? Easy. Well, it's easy, but in the quiz, do not say I didn't know that, okay? It's not easy. Math 001 is the most important course in the university, I think. Equals to what? Minus IS. What is the second equation? Minus 1 over R2 minus 1 over R2 times V1 plus حط كل شيء في الأقواس عشان ما تتوقع 1 over R2 plus 1 over R3 plus 1 over R4 1 over R2 plus 1 over R3 plus 1 over R4. You see it gets messy. Times V2. What is the coefficient of V3? Is minus 1 over R4. Plus minus 1 over R4. V3 equals. Is there any number here?
No.
So you have to put it equal to 0. What is the third equation? 0 times V1 plus minus 1 over R4 times V2 plus, put everything in brackets. 1 over R4 plus 1 over R5. V3 equals IS more minus. You put the negative. So this is one in the standard form. So now you open your calculator and you put all the entries here. A, B, C. So your A matrix would be a big matrix and then times V1, V2, V3 equals. I can give you that. It's going to be minus IS, 0 IS. And this one you get it from there. Get it? Example. This is a numerical example and I want you guys to solve it. So let's look. In this system, it's scary, right? But now we know a standardized approach. Any question in the previous example? It's time to ask questions. 1 or 2 problems in the major exam will be nodal voltage. And how to?
كيف أعرف موقع الجراند؟ كيف أقدر أحدد إن هذه؟
I told you, if he gives it to you in the test, it's given for you. If not, we usually put it at the lower level. ما راح نجيب لكم trick في الاختبار where you put the ground on the top, because that's stupid. I have never seen a circuit where they put the ground on the top except EE234 for EE student, and they want to put maybe one problem. And I think this is not a good way of teaching people. We're here to learn the process, and you keep it with you. So that's your answer. If he doesn't give it to you, put it at the door and move forward. Put your assumption. So we know it's a nodal voltage analysis if you see too many node current sources, صح? And we love current sources at nodal voltage analysis because they eliminate variables, صح? So what are the nodes? How many nodes in your system? Reference node 0, 1, 2, 3. This node is same as that node because these two elements are in parallel. So we write the process, V1. At node 1, use KCL. V1 minus V2 over 4 plus V1 over 5 plus 3.5 amps equal to 0. Any question about the first equation? The second equation, V2 minus V1 over 4 plus V2 minus 0 over 2.5 plus V2 minus V3 over 5 minus 3.5. Okay. This is going to be minus 3 plus. Okay, what's this current? Minus 3.5. So minus 3.5 equal to 0. That's why he put 3.5 here. Get it? So what's the current? The arrow current, the blue one. It's minus 3.5. So in the equation we said n equal out, so everything is out. Minus 3.5 equals 0. He skipped a step here and he put equal 3.5. I like it to be minus 3.5 equals 0 and then you fix it later in the standard form. Last equation, what's the blue current? Minus 2, so he put a 2 here. V3 minus V2 over 5 V3 minus 0 over 10. How to write it in the standard form? And now open your calculators. What's the standard form? 1 over 5 plus 1 over 4. Point 0.45 minus 1 over 4 minus 2.5 or minus 0.25. Is there anything with V3? 0. V1, V2, V3 equals. Plus 3.5, you put it to the right hand side, it's going to be minus 3.5. So now we're putting standard form. Math 001. The second equation, minus 1 over 4, which is minus 0.25. 1 over 4 plus 1 over 2.5 plus 1 over 5. 1 over 4 plus 1 over 2.5 plus 1 over 5 equals 0.85. Is there anything with V3? Yeah, minus 1 over 5, which is minus 0.2. Khums, minus 1.2. Equals 3.5. It was minus 3.5, you put it to the right. What's going to be? The last row, is there anything that has to do with V1? This is so far from V1. Sanity check. 0. Minus 1 over 2 is, minus 1 over 5 is 0.2, minus 0.2. And then 1 over 5 plus 1 over 10, and it's what? 0.6, right? 0.6? No.
0.3 should be.
1 over 5, oh yeah, 0.3. Equals 2. So this was minus 2 equals 0, you put it to the right. Now let's try to solve the system. This is your calculator. Mode, equation, number 2. Anybody doesn't know how to do it by calculator? Do it.
I did it. Find the value.
Okay, you solved V1, V2, V3?
Yes.
Okay.
Same.
Okay, what is the answer? What is V1?
-5.
Negative 5 volts?
5.
Is there any point something?
26.
Huh?
0.26.
Why?
Okay, now we have an argument.
You have -5, 5, 10.
Yes.
So I see V1 takes time is minus 5 volts. V2
5.
5. V3
10.
if you don't know, plug it. 0.45 times minus 5.
The last equation
Mine-
is not correct.
Hmm?
The last equation.
This is not correct?
Yes. Yes.
Why it's not
It
correct?
should be 0.3 V3. So negative 0.2 V2 plus 0.3 V3.
Yeah, this is not 5.35, it's just 0.1, 0.3.
Yes.
And if you fix it, then you would have
5, 5, 5, 10.
Believe me, in the test, these things are the ones that are taking time. So let's fix it from now. Yeah, but it doesn't matter. I actually used it this way. I didn't use the slide. Sure, it's still minus 5,
minus 5.
plus 5, and 10.
Plus 5, then 10, yes.
Minus 5, 5, 10. It doesn't matter, 0.35 or 0.3 doesn't matter. What was your answer?
Same. No, I don't have 5 point something. I have only 5.
Minus 5, 5, 10.
Yes. Yes.
Okay. So we both agree. It doesn't matter. 0.35. Yeah, that's a typo. It's 0. Okay? Fix it. I'm not going to fix it now. Maybe later. So any question how to solve this example? Anybody who doesn't know how to solve the equation? It's going to come in the test. 2 problems minimum for the major. He didn't solve the slides. He didn't even solve it. He even fixed it later. But I don't care. Let's do this example. Solve for the node voltage in figure 2.1 and determine the value of the current Ix. So he wants you to calculate Ix. You know now nodal voltage analysis, right? So try to step ahead of the game. We are smart. So he is asking for Ix. So what does that mean? If I know V1, if I know V3, I can calculate Ix. Why? Because we know the key of nodal voltage analysis is that Ix equals to what? Ix equals V1 minus V3 over 20. So if I know V1 and V3 in the nodal voltage analysis, and this is a common trick, they give you one unknown, they're expecting you to find V1 and V3 along the way. And as a general advice, ya shabab, in power systems or electrical engineering, if you know the voltages, you know everything. Because you already know in your system what are the resistors. You can measure it in the lab, you can have it in the models, in the simulations. Al-juhud voltages are where the energy is distributed in your system. So if you know V1 and V3, you can calculate Ix. Again, what is the reference? He's giving it to you. So where is 0 volts here? So let's do the equations. Did he solve them? He's asking no, he didn't solve this problem. Let's try to at least set up the equations.
Doctor, here, does it make sense that the current comes from the ground?
No, there is nothing. Okay. Again, I told you, current source, it imposes in your circuit the model. The current, when it goes to the ground, it doesn't mean it goes in the ground and vanish. No, it doesn't mean that. Ground has nothing to do where the current goes. Ground means, if I tell you there is a 5 volt here, it means I'm measuring 5 minus 0. It has nothing to do with this ground, where the current will go infinitely. So if the current comes from here, it comes actually from that cable, and from that cable, and they collect back here. Nothing will be fed from the ground. Ground has to do with voltages only. Get it? Basically, it tells you the reference is 0 here. So if you have 5, it means 0. If this was 1, this would be 6. Remember? Okay. Let's try to at least write the equations at node 1. So it's going to be, I'm going to do it quickly now. At node 1, so we have V1 minus 0 over 10 plus, don't say Ix, you don't know Ix. V1 minus V3 over 20 plus V1 minus V2 over 5 equals 0. What is node 2? N equal out. And we said everything in out in nodal voltage analysis. Everything is out. So you have V2 minus V1 over 5 minus 10 plus V2 minus V3 over 10 equal 0. What's the last equation? Node 3. It's going to be V3 minus V1 over 20, which is Ix, we calculated later, plus V2, V3 minus V2 over 10, plus V3 minus 0 over 5. Why I say minus 0?
Ground.
Because it's a standard process. We have to be professional and we have to put the 0, okay? You don't have to do it in the test, but I love to do it, so you guys have to do it, okay? Equals 0. Now, a very smart student who wants to get the A+, he would do the standard form right now. What's the standard form? Let's do it over there.
دكتور
Yes.
في أول ترم مو المفروض نحط الماينس عكس الآي إكس
Well, the first term,
نوت 3
this one, not 3, is going to be V3 minus V1 over 20. Out. We don't say Ix, we don't know Ix. The question asks about Ix. Later we'll solve it using the equations we wrote before, which is
الدايركشن هنا مو
you don't care about it. It's a standard process. Everything is out. Okay, why this is the direction not here, but we said minus 10 because we care about out. It's a standard process. You have to follow the procedure. Okay, what is 1 over 10 plus 1 over 20? 0.3. 1 over 10 plus 1 over 20 plus 1 over 5. Okay, 0.5.
Yeah.
For V2, minus 1 over 5, which is minus 0.2. For V3,
Minus 1 over 20.
which is
Minus 0.05.
minus 0.05, huh?
Yes.
Okay, equals 0, right? Because there is no current source. Let's do note 2. Minus 1 over 5, which is minus 0.2.
Plus 1 over.
This one.
Yes, plus 1.
And then V2 is 1 over 5 plus 1 over 10, which is 0.1 plus 0.2, which is 0.3, right? For V3, what do we have? Minus 0.1 equals
Equals 10.
10. Always the DCs, the constants, we put them to the right, and math 001. What's the last equation? For V1, we
1
have
over 20.
minus 1 over 20, which is minus 0.05, minus 1, which is minus 0.15.
Why minus?
Minus because minus 1 over 20 minus 1 over 10.
This is supposed to be V2. I think. Yes.
Oh, this is V2?
Yes.
Okay, I'm sorry. So it's going to be minus 0.05. What is V2?
Minus 0.1.
Minus 0.1. For V3 we have 1 over 20 plus 1 over 10 plus 1 over 5. 1 over 20 plus 1 over 10 plus 1 over 5. 0.35 equals
0.
0. Let's solve it. .5 minus 0.2 minus 0.5 0 minus 0.2 0.3 minus 0.1 10 minus 0.5 minus 0.1 0.35 and 0. And if you solve it, and correct me if I'm wrong, V1 is 24.39 volts, V2 is 56.097 volts, and V3 equals 19.5. Am I right or wrong? I think I'm wrong. Correct?
The same.
You got the same answers. That's how I want you to solve it in the test. Get your calculator, start the process, standard form, using a calculator. Any question about this problem? What if I replace the current source with the voltage source? Let's think, what will happen? We will reduce the number of variables to only 1 and 3 because we already know V2. And that is this example. So at this node, we're going to call it node 3, 10 volt, we already know it's 10 volts. So you only need to know V1 and V2. Now this was V3 before. So to solve this problem, we again, it's a standard process. We have to start from scratch.
I think there's wrong in the
This
entry.
one, 0.35.
0.35.
Are you sure?
Yes,
Because
yes.
it's 1 over 10 plus
Yes, yes.
1 over 20 plus 1 over 5.
Yeah.
Okay. 0.35?
Yes. And first one should be 45.45.
Second one?
The second one 72.72.
72. Third one?
Third one 27.
Right?
Yes.
Yes.
Okay, I apologize. See, if you make one mistake, get it? I'm gonna write these equations. I'm not gonna solve them. So how many nodes we have? Only 2 nodes. So node 2 now is known. It's 10 volts. So let's start the process. At node 1, it's gonna be V1. It's gonna be minus 1 plus V1 minus V2.
V3, it's
No, we call it V2 now. We don't call it V3. Over 5 plus V1 minus 10 over 2 equal to 0. V1 minus 10. What did I tell you about the voltage source? We know it's already 10. V1 minus 10. At this node, node 2, what we'll have? V2 minus V1 over 5 plus V2 minus 10 over 10 plus V2 minus 0 over 5 equal to 0. Standard form. How do we do the standard form? We need to reduce the equations to 2 knowns, 2 unknowns. Let's do it real quick. 1 over 5 plus 1 over 2 is going to be 0.7, right?
yes.
Minus 1 over 5, which is minus 0.2. So this has a size of 2.2 equals to 5 plus 1, 6. 1 plus 5 is 6. This equation, I'm going to take some time. You can leave if you want. Minus 1 over 5, which is minus 0.2. What is for V2 what we have? 1 over 5 plus 1 over 10 plus 1 over 5. That's 1.1. No, 0.4, 0.9, right? 1 over 5 plus 1 over 5 plus 1 over 10. No, it's 0.5. 1 over 2. 1 over 5 plus 1 over 10 plus 1 over 5.
1 over 4.
5.
نص صح؟
Yes.
Equals
1.
minus 1, it will be there, plus 1. Let's solve the system. Again, 5 equation, the first one, 0.7 minus 0.2, 6 minus 0.2, 0.5, 1. So what is V1? 10.32 volts. What is V2? 6.13. متأخرين. Any question about this example? Is it clear? I'll stop the recording.